Hey, everybody. Okay, so today we're going to talk about the different jobs that various organisms have in an ecosystem as it relates to the way that energy and atoms pass through the ecosystem. To an ecologist, plants and animals, us, we all are just vessels. We're like buckets for atoms and energy. And the atoms and energy move from bucket to bucket. And so from an ecologist standpoint, we're just one moment in the passing through of these atoms and this energy. And we each play a different role in the way that energy and atoms pass around. Most of the energy and atoms are passing from organism to organism by being eaten or eating, but not all. So we're going to go over the vocabulary that scientists use to describe all the different jobs that organisms or niches that different organisms have in an ecosystem as relates to the way that atoms and energy are passing through. So if we take a look, we have lots of different kinds of organisms. We have plants that can take energy from a place like the sun or the hydrothermal vents that we talked about yesterday, right? Or last time. So we've got an organism that can use an energy source and takes in carbon dioxide and water, inorganic compounds, and makes food, organic compounds. And now the energy that was in the sun and the atoms that were in the carbon dioxide and water are actually in the plant. They are producers, right? And they then are eaten. Now, the deer is just looking for a lunch, but from an ecologist's standpoint, what's happening is the atoms and energy that were inside the plants are now inside the deer. Different bucket, same energy, same atoms moving along, okay? And that deer can't walk a walking, chewing vessel of atoms and energy gets snagged by a hunter that hunts him down and kills him and eats him. From an ecologist, it's very vicious, right? It's really sad to watch, but from an ecologist standpoint, all that is a transfer of atoms and energy from here over to here. And now the atoms and energy are inside the lion. Now, if any of these things die at any particular time without getting eaten, it's not like the energy and atoms are going to stay trapped in them forever. If it was, we could look out the window today and we would see piles and piles of dead dinosaurs and woolly mammoths and people never having rotted. They would be perfectly preserved. All the atoms and energy would still be in them. They might have gotten rained on and snowed on and looked pretty yucky, but they wouldn't have rotted. Because what rotting is what our next organism does. It takes those atoms and that energy, it uses the energy and it recycles the atoms into a form that the plants can use. And so the atoms in this plant might have once been part of a dead lion. In fact, the atoms in your cheek might have been part of a dinosaur at one point, and it's just been cycling through and cycling through and cycling through. And ecologists are just watching those atoms and the energy passing around. Okay, so let's get the vocabulary for all that. We're going to start with the things that can trap energy and make food out of it. We have learned earlier that things that can make their own food are called autotrophs. But in this context, in ecology, their job in relation to everybody else is they are producers. They are producing the food that other organisms need. They are producing organic compounds by trapping energy. Now, that's the autotrophs, the producers. Now we have the heterotrophs. And remember, heterotrophs are things that can't make their own food. We actually have a couple of categories of heterotrophs. We've got those that eat. Those are called consumers, and those that decompose things, they're called decomposers. So we have our consumers. The deer is a consumer and the lion is a consumer because they eat. And then we have mushrooms and fungi and bacteria that decompose. Oops. Okay. So we have our autotrophs, they're the producers. We have our consumers and decomposers that are both heterotrophs. And then we have lots of different kinds of heterotrophs. We've got plant eaters. They eat only plants, like the deer, right? Those are called herbivores. Plant eaters are herbivores. And meat eaters are carnivores, like our lion. And then we have our decomposers, like the fungi and bacteria. Carnivores come in various varieties. So remember, carnivores are the meat eaters. right? Carne means meat. Vor is the word to mean voracious or hungry. It has to do with eating. So this is a meat eater. Meat eaters come in a couple of varieties. You have some, like the lion, that hunts and kills its food. Really great hunters. Those are called predators. Predators kill and consume their food. Their food is called prey with an E, not prey with an A. So here we have a bobcat hunting and killing a snow hare, a rabbit, essentially. And the cat here is the predator. The rabbit is the prey. Now, they're both consumers. They're both heterotrophs. The bunny's an herbivore, doesn't eat meat, only eats plants. The bobcat's a carnivore. But in this particular relationship, this carnivore is also a predator, and this herbivore is a prey. We also have those carnivores who don't like to hunt. They're lazy. They like to wait for dead food to show up. They're scavengers. So we have lots of organisms that come along just waiting for dead food to scavenge on, and they're the scavengers. So that's carnivores, meat eaters, herbivores, plant eaters, and then there's the ones that eat both, like us, right? A perfect example would be bears. Bears love to eat fish. They love to eat berries. They are omnivores. They eat both plants and animals, just like us. We're omnivores as well. And then we have our last group of heterotrophs, the decomposers. The fancy word for that is saprophytes. We won't worry about that. So the decomposers recycle dead stuff. But wait a minute. Now, just a little while ago, I said we had stuff that ate dead stuff that's called scavengers, right? We've got our scavengers eat dead stuff. Now I'm saying decomposers eat dead stuff. So which is it? Are they decomposers or are they scavengers? Well, they both feed on dead stuff, but their job in relation to that dead stuff, totally different. These guys are eating that dead animal, and those atoms and energy are inside of them, period. Bacteria and fungi eat that dead stuff and recycle it into a form that can be used by plants. So decomposers and scavengers both live on dead stuff, but they do very different things with it. Scavengers eat dead stuff. Decomposers recycle. They break down dead things and waste, like poop, right? They decompose that and recycle it. And if we did not have decomposers, we would have a situation where we'd have piles and piles of dead dinosaurs and all sorts of things that would never have been recycled. And there wouldn't be enough atoms to make us. We wouldn't be here. There would just be dead things. And the atoms would all be in the dead things. There'd be no living things with atoms in them. So that whole recycling thing's really, really important. We tend to think you can't have an ecosystem without producers, but you can't have a self-sustaining ecosystem without decomposers either. Otherwise, everything ends up trapped in dead animals. And so those are the vocabulary words that talk about the different ways that organisms serve a role in passing energy and atoms through an ecosystem.